Hello, it's Professor Asma Parveen from Department of Psychology, Aligarh Muslim University. Welcome back to the course on fundamentals of research. Today I will be continuing with the topic sampling. And one of the important concepts related with the sampling is the sampling variability and precision. Sampling variability refers to the natural variation that occurs when different samples are taken from the same group of the population. This variation is a result of the randomness in selecting the sample and has an impact on the consistency of our estimates based on these samples. Understanding sampling variability is crucial in determining the reliability and stability of our research findings. By recognizing and accounting for this variability, we can ensure the accuracy of our conclusions. To better understand sampling variability, imagine you have a bag of marbles with different colors. If you randomly select a handful of marbles from the bag, each time you do so, you may end up with a slightly different combination of colors. Similarly, when we take different samples from a population, we may obtain slightly different results each time due to the inherent variability in the individuals selected. This concept highlights the importance of considering multiple samples to obtain a more comprehensive understanding of the population. The presence of sampling variability can affect the generalizability of our research findings. When we conduct a study using a sample, we aim to make inferences about the large population from which the sample was drawn. However, if the sampling variability is high, it becomes challenging to confidently generalize our findings to the entire population. In such cases, our estimates may not accurately represent the true characteristics of the population, leading to potential biases or inaccuracies in our conclusions. Sampling variability refers to the differences that can occur when taking samples from a population. This means that even if we take multiple samples from the same population, we might end up with different results. There are several factors that can contribute to this variability, and one factor is random sampling, which means that each member of the population has an equal chance of being selected for the sample. This randomness can lead to different results across different samples. So, if you were to randomly select a group of people from a population, you might get different characteristics and values each time. Another factor sampling variability is the population heterogeneity. It means that the characteristics of the population can vary. This variation affects the distribution of values in the sample. For example, if you are studying the heights of people in a city, the heights might vary across different neighborhoods or age groups, leading to different results in your samples. The size of the sample also plays a role in sampling variability. Smaller samples tend to have more variability compared to large samples because there are fewer observations to represent the entire population. So, if you only survey a few people, their characteristics might not accurately reflect the whole population. Lastly, the method used to select samples, such as stratification or clustering, can introduce additional sources of variability. These methods can affect how representative the sample is of the population. For instance, if you use stratified sampling and divide the population into different groups, the characteristics within each group might be more similar, leading to less variability in your samples. There are certain implications of this sampling variability because when we make estimates about things like averages, means, proportions, or regression coefficients, there is always some level of uncertainty. And this uncertainty is caused by the natural variation that occurs when we take a sample from a larger population. To account for this uncertainty, we use confidence intervals. These intervals give us a range of values within which the true population parameter is likely to fall. They provide a measure of how confident we can be in our estimate. considering the variability in the sample. Another way to quantify the precision of an estimate is through the margin of error. The margin of error tells us how much the estimate might vary due to the variability in the sample. A smaller margin of error indicates that the estimate is more precise, while a larger margin of error suggests less precision. Understanding these concepts is important because they help us interpret and evaluate statistical estimates. By recognizing that there is always some level of uncertainty in our estimates, we can better understand the limitations of our findings. Confidence intervals and margins of error provide valuable information about the range of possible values of a population parameter, allowing us to measure the reliability of our estimates. For example, if we are estimating the average height of all students in a school, a confidence interval can tell us that we are 95% confident that the true average height falls within a certain range. This means that if we were to repeat the sampling process multiple times, 95% of the resulting confidence intervals would contain the true average height. So, sampling variability influence our population parameters, confidence level, and margin of error. The next concept is the concept of precision. Precision is a key factor in determining the accuracy and consistency of measurements or estimates. In the context of sampling, precision refers to how closely the sample estimates align with the actual population parameter. The lower the variability in the sampling process, the higher the level of precision achieved. This means that when conducting research or gathering data, it is important to minimize any fluctuations or inconsistencies in order to obtain more precise results. By doing so, we can increase the reliability and validity of our findings. Measuring precision is an important aspect of data analysis. In order to determine how accurate our sample estimates are, we can use two different methods. First is standard error, and the second one is coefficient of variation. The first method, that is standard error, takes into account both the size of the sample and the variability of the population. It helps us understand how much our sample estimates vary from the true population parameter. Essentially, it gives us a sense of how reliable our data is. On the other hand, the coefficient of variation provides us with a relative measure of precision. It expresses the standard error as a percentage of the mean. This allows us to compare the precision of different sets of data regardless of their scale or units of measurement. By using these two methods, we can gain a better understanding of the accuracy and reliability of our data. Standard error help us assess the variability of our sample estimates, while the coefficient of variation gives us a way to compare precision across different data sets. There are certain factors that can affect precision. One important factor is the size of the sample. When the sample size is increased, it tends to improve precision because it reduces the amount of variation that comes from sampling. In other words, a larger sample provides a more representative picture of the population being studied. Another factor that affects precision is the method used for sampling. Different methods, such as stratified or cluster sampling, can increase precision by reducing the variability within smaller groups or clusters. By ensuring that each group or cluster is well represented in the sample, these methods help to capture the diversity of the population and minimize potential biases. The variability in the characteristics of the population being studied can also impact precision. If there is a high level of variability in the population, it can decrease precision because it leads to a wider spread of values in the sample. For example, if a study is examining the heights of individual in a population where there is a wide range of heights, the sample may not accurately represent the true distribution of the heights. This can result in less precise findings. Practical considerations. Power analysis is a crucial tool in research that helps us determine the likelihood of finding true effects or differences based on our sample size. It takes into account factors such as the variability of our sample and how confident we want to be in our results. This is important because we need to strike a balance between the precision of our findings and practical considerations like time and resources. When interpreting our results, it is essential to acknowledge the presence of uncertainty due to sampling variability. In other words, our findings may not be entirely accurate, and we should keep this in mind when drawing conclusions. Understanding the concepts of sampling variability and precision is vital in research as they directly impact the reliability and accuracy of our findings. By grasping these concepts, researchers can make informed decisions about their samples, ensuring that they are representative and appropriate for their study. Additionally, understanding power analysis allows researchers to correctly interpret their results, taking into account the potential limitations and uncertainties associated with their findings. Ultimately, this knowledge empowers researchers to draw meaningful and valid conclusions from their research. Why is sampling important for researchers? Sampling is a valuable tool for researchers to gather information about a large population without having to study every single individual. By selecting a smaller sample group, researchers can save time and resources while still obtaining meaningful data. This process involves studying the selected sample repeatedly, allowing for a deeper understanding of the population as a whole. Sampling offers several advantages, including the ability to make accurate predictions and generalizations about the larger population based on the findings from the sample. It allows researchers to identify patterns within the population, providing valuable insights for further analysis. So, sampling is an efficient method for gathering information and drawing conclusions about a larger population. One major advantage of sampling is its ability to save time. Contacting every single person in a population can be a time consuming process, and there is no guarantee that everyone will even respond. By using random or non random sampling techniques, researchers can gather data much faster than surveying everyone. This allows them to invest less time in follow up efforts and focus more on analyzing the collected data. Another important advantage of sampling is it also helps researchers to save money. The number of people a researcher contacts directly affects the cost of a study. By selecting a sample that represents the population, researchers can gather the same answers and data that they would receive from the entire population, but at a fraction of the cost. Non random sampling is particularly cost effective as it reduces the expenses associated with finding people and collecting data from them. Given that research is typically conducted on a budget, saving money is essential. Furthermore, sampling enables researchers to collect rich data. Depending on their research goals, researchers may want to collect a small amount of data from a large number of people or gather extensive information from a few individuals. Sampling allows researchers to ask participants more questions and gather more detailed data compared to contacting everyone in a population. This is particularly useful in studies such as opinion polls, user studies, or ethnographic interviews where detailed information is necessary. Sample size and its determination. Determining the appropriate sample size is a crucial aspect of analyzing data. The question at hand is how big or small the size should be. If the sample size is too small, it will not yield accurate results and will not help us achieve our objectives and goals. Conversely, if the sample size is too large, it can become costly and consume excessive resources. The ideal sample size lies in finding the balance, not too big and not too small. It should be sufficient enough to provide confidence interval of the desired width. To determine the appropriate sample size, researchers must consider various factors that influence the accuracy and reliability of their studies. And one factor is the nature of universe. The population is very vast and complex entity with the potential both for uniformity and diversity. If everything within the population follows the same patterns and characteristics, then studying a small sample can provide valuable insights into the nature of the population. However, if there are variations and differences within the universe or population, a larger sample size would be necessary to accurately capture its complexity. So, when conducting in depth and long term studies, it is often more effective to focus on a small sample because this allows researchers to deeply understand the intricacies of their subject matter and gain a comprehensive understanding. On the other hand, when seeking a general overview or conducting technical surveys, a larger sample size is typically required to ensure statistical validity and representativeness. In situations where the goal is to create distinct groups or categories within a study, a large sample becomes essential. A small sample may not contain enough items or individuals to adequately represent each group, leading to skewed results and incomplete conclusions. By utilizing a larger sample, researchers can ensure that each group is properly represented and accounted for, allowing for more accurate analysis and interpretation. Statistical methods can be used to determine the minimum number of participants required to obtain reliable results. This calculation takes into account the desired level of precision and confidence in the findings. By ensuring an adequate sample size, researchers can have greater confidence in the validity of their conclusions. Another important factor is the sampling technique. The size of a sample in a study is also determined by the type of sampling technique used. This decision is crucial because it directly impacts the accuracy and reliability of the results. Different sampling techniques require different sample sizes to ensure representative data. Therefore, researchers must carefully consider the appropriate sample size based on the chosen sampling technique. The desired level of confidence in a study's finding is critical factor in finding the appropriate sample size. A higher level of confidence necessitates a larger sample size to minimize the margin of error and increase the reliability of the conclusions. Conversely, a lower level of confidence may allow for a smaller sample size, but this could potentially compromise the accuracy and dependability of the study's findings. For example, if researchers want to be 95% confident in their results, they would need a larger sample size compared to being 90% confident. The desired level of confidence influences the sample size needed to ensure reliable and accurate conclusions. One factor to consider when determining the sample size is the level of precision required. Researchers need to establish desired width of the confidence interval, which represent the range within which the true population parameter is likely to fall. A narrower confidence interval indicates greater precision, but this requires a larger sample size. On the other hand, a wider confidence interval allows for more variability but requires a smaller sample size. Therefore, the level of precision needed plays a significant role in finding the appropriate sample size. Another factor that is also important is time and resources. The time and resources available for data collection should not be overlooked when determining the appropriate sample size. A larger sample size demands more time and resources to collect, process, and analyze the data effectively. So, the time available to complete the study is a critical factor in determining the sample size. Conducting research takes time, and researchers must consider the feasibility of collecting data from a large sample within the given time frame. If time is limited, it may be necessary to reduce the sample size or modify the research design to ensure timely completion. Researchers must carefully evaluate their limitations and constraints to ensure that the chosen sample size is both practical and achievable within the given time frame and available resources. The choice of sample size is also crucial for obtaining accurate results. The nature of sample being studied plays a significant role in finding the appropriate sample size. For example, if individuals are the focus, a larger sample size may be necessary compared to studying households or the organizations. So, understanding the characteristics of the group being studied help researchers to find out the number of participants needed to ensure a diverse representation. Size of population is also important when we are considering the sample size. Generally, a larger population requires a larger sample size to accurately represent it. However, there is a need to find a balance between sample size and the feasibility. Conducting research on a massive scale is not always feasible due to limited resources, time constraints, and logistical challenges. Therefore, researchers must carefully assess the size of the population and make decisions regarding the sample size that will yield meaningful and reliable results. Another important factor is that we should take into account the availability of the finance. The amount of money allocated for the study directly affects the size of the sample that can be obtained. It is important to consider this because a larger sample size can lead to higher cost in obtaining accurate estimates through sampling. Therefore, researchers must carefully balance their budget with the need for a representative sample. Another factor that we should take into account is the size of questionnaire. The length and complexity of a questionnaire can also have an impact on the number of people that need to be surveyed. When a questionnaire is long and complicated, it may be necessary to survey more individuals in order to ensure enough data is collected. This is because having a larger sample size allows for a more accurate estimate of the results and decreases the likelihood of error. Conversely, if the questionnaire is short and straightforward, surveying fewer people may still yield reliable results. The key factor here is finding the right balance between the length and the complexity of the questionnaire and the number of people surveyed. In addition to participant numbers, having an adequate number of trained investigators is another important factor. Researchers must ensure that they have qualified staff members who can effectively collect data from the selected group of individuals. If there is a shortage of trained investigators, the study may need to either reduce the number of participants or allocate resources towards training additional staff. The presence of sufficient staff is vital to ensure the research is conducted properly. Another important factor that researchers must carefully consider are the conditions in which the sample is being taken. Factors such as the location of the study, the cultural context, and the dynamics of interpersonal interactions can also influence the number of people that should be included in the sample. It is crucial to ensure that the sample accurately represents the population of interest, which may require over representing certain groups. Additionally, adjustment to the sample size may be necessary depending on the specific details of the study, such as accounting for potential dropouts or non responses. These considerations are essential for obtaining reliable and valid results. Another important factor is variability. Variability also help us to find out the appropriate number of participants in a study. Factors such as the diversity within the group and studies design play a significant role in this decision making of sample size. Generally, including a larger number of individuals in a study leads to more accurate results and strengthens the statistical analysis. With an increased sample size, researchers are able to minimize errors and enhances the reliability. By having more participants or data points, the researchers can ensure that their conclusions are more trustworthy and robust. Conversely, if the population has low variability, a smaller sample size may suffice as the characteristics are more homogeneous. However, it is important to note that simply increasing the number of participants does not guarantee better outcomes. The quality of the data collected and the methodology employed are equally important. Researchers must ensure that the individuals included in the study represent a diverse range of characteristics and backgrounds to obtain comprehensive results. Additionally, the study's design should be carefully planned to address specific research questions and objectives. A well designed study with a sufficient number of participants will yield more reliable and valid conclusions. Another important aspect of sampling is the principles of sampling. And the principle one is when we want to learn about a larger group, like all the students in our school, it is not always possible or practical to collect data from every single person. Instead, we take a sample, which is a smaller group of people that represents the larger group. However, when we do this, there will usually be some differences between the information we get from the sample and the true mean of the whole population. This happens because we have to choose specific individuals to be in the sample and they may not perfectly represent everyone in the population. So, when we make conclusions based on the sample, we have to keep in mind that there might be some variation from the true mean of the population. This difference is attributed to sample and known as sampling error. Sampling error is the difference between the sample statistic and the true population parameter. It occurs due to chance and is unavoidable. However, by increasing the sample size, we can reduce the impact of sampling error. When we have a larger sample size, the random variations that occur in the sample have less influence on our conclusions. This means that our conclusions are more likely to be closer to the true mean of the whole population. So, if we want to minimize the effect of sampling error, we should aim for a larger sample size, and this is principle 1 of sampling. Principle 2 of sampling is associated with certain other factors. Having a larger sample size is crucial for obtaining accurate findings, but when we increase the size of our sample, our estimate of the true population mean becomes more precise. This is because larger sample size diminishes the significance of random differences and allow us to make a more informed guess about the average for the entire population. By including more data points in our analysis, we can reduce the margin of error and increase the reliability of our conclusion. Therefore, it is essential to consider the sample size when conducting research or drawing conclusions based on data. So, the second principle is larger the sample size, the more accurate our results will be. When conducting a study, it is again important to consider the diversity of the population being studied. If the population is diverse in terms of the variable being studied, a larger sample size is necessary to obtain accurate results. This is because a diverse group will have more variations and differences, requiring a larger sample to capture the full range of perspectives and experiences. So, it is important to recognize that the magnitude of the difference in what is being studied within the population will impact the difference between the results obtained from the sample and the true mean of the entire population. In other words, if there is a significant difference in variable being studied among the population, the results from the sample will likely deviate more from the true mean. Therefore, researchers must consider the composition of their sample and ensure it adequately represent the diversity present in the population. By doing so, they can minimize bias and increase the reliability and validity of their findings. So, third principle of sampling is the more diverse the population is, the more likely the sample statistics will deviate from the true mean of the entire population. These three principles suggest that when analyzing a sample to draw conclusions, two factors must be taken into account. The first is the size of the sample itself. Generally, a larger sample size will yield more reliable and accurate findings compared to a smaller one. This is because a larger sample better represents the entire group of people being studied. The second factor to consider is the variation within the population being studied. If there are significant differences in the characteristics being examined, using a small sample can make it challenging to draw solid conclusions. However, if the group of people shares similar characteristics, even a small sample can provide a fairly accurate idea. So, by considering both the size of the sample and the variations within the population, researchers can ensure that their conclusions are robust and applicable to the population. A larger sample size increases the likelihood of capturing the true characteristics of the population, while a smaller sample can still be informative if the population being studied is relatively homogeneous. This is all for today. Thank you.